So second type of crystalline solid is covalent crystals. So the name itself tells that the constituent particles are held together by covalent bond. So in covalent crystals, naturally the atoms are present. The atoms are held together in three dimension by a network of a covalent bond. We know covalent bond is formed by mutual sharing of a pair of electrons. So you can consider diamond as an example, hardest crystal. Diamond has only carbon atoms, no other element. So carbon atoms are held together by covalent bonds. It gives a very big three-dimensional network. You are going to study about the structure of diamond in the second unit in the chemistry later. So the covalent crystals contain atoms held together by covalent bonds. So this leads to a close-packed three-dimensional network. So they also possess high melting point. They are also harder substances. But compared with ionic crystals, the covalent crystals are poor conductors of heat and electricity. So this is about a covalent crystal. So ionic crystal is an ionic bond. Covalent crystal, atoms are held by covalent bonds. Next we move on to molecular crystal. So molecular crystals naturally contain neutral molecules which do not possess any charge. So these crystals are comparatively soft and possess low melting point compared to ionic and covalent solids. The molecules are held by weak physical forces like van der Waals force, London forces, and dipole-dipole interaction. So these molecular crystals are further classified into three types, depending upon the nature of the force which hold the molecules. One is polar molecular solid, another is non-polar molecular solid, and third is hydrogen bonded molecular solids. So let us get into the polar molecular solids. Polar molecular solids. Polar means which have charge. So just now you told you that the molecular solids do not possess any charge, but anyhow, when you consider a covalent molecule, say A and B atoms try to form a covalent bond, means A gives one electron, B gives one electron. So this pair of electron is mutually shared by both A and B. This leads to covalent bond. So a covalent bond has a pair of electron mutually shared by these two atoms. If these two atoms are same, say A, the electron pair is equally shared by both A and A. So the electron pair shared equally means both A and another A do not develop any charge. This is called a non-polar molecule. On the other hand, if we have two different atoms, this heteronuclear molecule, two different atom means, so this is one atom, this is another atom, they differ in the nuclear charge, number of protons. In covalent bond, two electrons are being shared. If two different atoms are present with a different nuclear charge, the attraction will not be equal. An atom having more nuclear charge attracts the electron more. The other atom with less nuclear charge has less attraction. So this is not mutual sharing. As a result, the electron pair moves towards more electronegative atom. I hope you remember electronegativity. Electronegativity is the tendency of an atom to attract the electrons, that is the shared electron in the covalent bond, towards itself. See, this atom attracts the shared pair of electron towards itself. This is called the electronegativity. This is more electronegative, this is less electronegative. More electronegative means the electron is attracted more towards A and less towards B. So A develops a small partial negative charge and B on the contrary possess a small positive charge. So this charge development leads to polar nature. So this is called a polar molecule, or sometimes it is called a dipole molecule. So we have studied all these in 11th standard itself. So we have two types of molecules, namely non-polar molecule and polar molecule. Non-polar molecules do not develop any charge. So if you consider this is a non-polar molecule, another non-polar molecule, then how they are held? They are held by weak physical forces called the van der Waals force, naturally intermolecular forces. Because of the positive charges in nucleus and the electron, naturally this electron is attracted by the next nucleus, and this nucleus attracts the electron of the next molecule. This is weak force, natural force. This is called the van der Waals force. Sometimes, depending on the nature of the molecule, is called Lambert forces. So this is weak. So these are present, these are operating in the non-polar molecules. So these forces are weak. So these non-polar molecular solids are soft, possess low melting point. Example, naphthalene that we use to repel the insects in the cloths. Naphthalene, anthracene, these are all organic compounds. But these non-polar molecular solids are normally at room temperature are liquids or gases. Then how come they are called solids? They can be liquid, they can be compressed. By reducing the temperature, lowering the pressure, they can be converted into solids. So they are non-polar solids in which weak forces operating, neutral molecules, they are soft versus low melting point. Example, naphthalene, anthracene, etc. Then coming to polar molecular solids. So in which two different atoms are held by covalent bond having partial charges. This is called a dipole molecule. If this is a dipole molecule, another dipole molecule. So consider different dipole molecules. So because of the charge present, they have slight attraction to the next molecule. So this leads to attractive force. This is called a dipole-dipole interaction. Dipole-dipole interaction. This is slightly stronger than the attractive force in the non-polar molecules. So this leads to slightly higher melting point than in the non-polar solids. Example for this are solid carbon dioxide, solid NH3. So these are the second type of molecular solids. They are called polar molecular solids.